So our next link challenge involves counting pets. We start off with a string of various types of animal, and what we want to do is count how many dogs there are, how many cats, and how many are there of any other type of animal. So the output needs to say that there are 5 dogs, 3 cats, and 4 other animals. And as with our previous link challenges, if you want to try this yourself, why not pause the video now, load up LinkPad or Visual Studio and give it a go. And this one can be solved quite easily using one of the built-in extension methods. Okay, so how did you get on? Did you work out which link method can help us here? If you guessed group by, then you were right. We can solve this challenge very easily by splitting the input string on a comma and then calling group by. And if we do that, we can see that we get all the pets grouped by the type of pet, all the dogs, cats, rabbits, and so on. Now this isn't exactly what we wanted, as we only wanted the total number of pets. And so we can add a select to the output of group by and say that we want to select an anonymous object with the type of the pet, which is going to be the key of each of the groups that came out of group by, and the count of the items in that group, which we can use LINQ's count extension method for. And so now when we run this, we've got the count of each type of animal. But of course, we said that we were only wanting to count dogs and cats explicitly, and all the rest of types of pet were to be counted together. And we can achieve that by changing the key selector lambda that we pass into group by, so that it uses other as a key if the pet isn't a dog or a cat. And so that was quite simple to solve, but there's one thing I don't like about this solution, and that's that group by needs to build up a dictionary that contains a reference to every single pet in the input sequence in order to work. Now, for a tiny data set like this, who cares? But if we had several million items of input data that we were wanting to count, then creating a gigantic dictionary to do so would be overkill. So what we really want in this situation is a count by method, which only keeps track of the keys and the running total of elements that have that key. Now, as it turns out, this is something that comes out of the box with the F# language. It's got a count by method in its seek module, which would be ideal for solving our problem. And by the way, I often find that looking through the collection processing methods available in other languages like F# sequence module or Python's itertools module can be a great source of inspiration for extension methods that might be useful in C#. But LINQ doesn't have a count by method, and count by also seems to be one of the few methods that the MoreLINQ NuGet package doesn't seem to have got round to implementing yet. So let's see how we could make it ourselves. And thankfully, this one is a little bit simpler than the max by implementation we looked at earlier. So our count by method is going to return an IEnumerable sequence of key value pairs. The grouping key, which will be an animal in this case, and an integer count of how many items there are with that key. And the count by method itself is an extension on an IEnumerable sequence of source elements. And it takes a key selector function that turns each source element into the key that we want to count by. Now, before we talk about the implementation, notice the fact that this is a completely generic method. We can use it to count sequences of any type of object. And the keys don't have to be strings either. And this is a great habit to get into when you're creating your own extension methods. Try to make them generic wherever possible, and that will maximize the reuse you can get out of them. So how can we implement this count by method? Well, I've just done something really simple here. I've got a dictionary of key to integer, which basically maintains the running total for each key. Then we iterate through our source collection and calculate the key for each item in the source by calling our key selector function with that item. And if this is the first time we've seen this key, then we'll need to add it to the dictionary with a count of 1. Otherwise, we'll just increment the count that we've already got. And then when we're done, we can simply return our dictionary as it already implements IEnumerable of key value pair. And so now we can replace our call to group by and select in our initial solution with a single call to count by and get exactly the same results as before. And yes, although this is only a small refactoring, it allows us to express our intent more clearly, as well as having the knowledge that the underlying implementation is better optimized for the task at hand than our previous solution. Okay, let's attempt another LINQ challenge now, and this one will really show off the benefits of the LINQ library.